most people call me Happy. I've been working with programming language implementations for many years. I've been working with Scala and Erlang, and for last year I've been working with smart contracts for Eternity. Today I'm going to talk about Sophia, the functional language. We'll talk a little bit about Eternity and the background for that. I will not talk so much about all the features of Eternity that we have, but just a little bit about the background as it affects the design of the language, and talk at all really, but the global scalability is not so much the goal of this talk either. That has more to do with how that we're using Bitcoin in machine, but also by having many of the objects that you would find being used in, for example, Ethereum over and over again as quite heavy and expensive smart contracts. We've lifted them up for the contract and smart contract execution. We wanted it to be safe, efficient, and to scale, and to be cheap. We also wanted there to be a way to migrate from Ethereum to virtual machine contracts. To get cheap execution, we have a new language that it's called Varna, that should be cheap, and this can be Sophia contract. You will see what is happening, and it's strongly typed so that you cannot mix up the way you're using functions and variables, but do not be able to compile programs that uses these values in the wrong way. With a functional language, it should also be simpler to do proof of the language, something that we hope to take advantage of soon. And at least as I see it, with a functional language you get shorter and more readable code. In imperative language and in a functional language, trying to sum the values between 1 and 100 and also storing them in an array. So actually I managed to make two mistakes, or actually 3 mistakes, when I wrote the imperative version of the program. This loop will never end. That's not really a bug that you get with any support from a functional language to get rid of, but just that this would actually sum up all the values in the array, but since the first value of sum and also the first value 0 are undefined, we don't really know. More complex, but once you have learned it, very easy to see and read is things like the full function that takes an accumulator and a list of values in this case, and then applies this function that takes the argument x from the list of values and y from the. We send this function to the full function and apply it to each value here, adding the values together, and we start from 0. So a very concise way of doing summing the values in the array. So even if I hadn't made the mistakes in this code, the code here is a bit more verbose and hard. Also has significant white space, so you don't have to use blocks, curly brackets or semicolons to show the block structure of a program or the scoping. So let's look at some examples of Sophia code. Here we have a simple storage contract that handles state. So Sophia contracts start with the keyword data and integer, or a record actually, with field data and an integer. The function init is a special function that is automatically called when you just read a value or actually update value in the state. Sophia also supports calling other contracts, and when you call another contract you have optional and gives back an integer. So in this case this is only an abstract declaration of this contract, so that we may use it in the real contract that we're defining right now. So in takes an integer and gives back an integer. What it does, we don't really know from the code here. From the name we can guess that it will actually increment some state with the integer that we give it, and perhaps the argument x that will be used to increment the value. So the ink server might charge a fee for keeping this this state to be incremented, for example. And you want to call with the dot in between them and then the arguments to that function. For built-ins, it looks basically the same. So there's a number of contracts. There's a query function in the Oracle contract that takes a number of arguments. So you can create a new function called createQuery, which takes an Oracle ID, a query type, and a fee, and some time to live for this query. And you may check that you actually have enough arguments. Sophia also has variant types, so you can define your own types. Like, for example, here we define our own data type complex question, constructor of the type. There's a built-in type that's called option. It has two values, one none and then some of some type. So we can put this together. Variant type